Hi everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we'll look at Lesson 6 from Chapter 5, which is talking about properties of linear relations. So a linear relation is an equation that makes a straight line when it's graphed. It also has a constant rate of change. So a constant rate of change is when you're moving up or down on your graph by the same number every time you move one square to the right. And then another property is that the equation only contains one or two variables, and one thing that's really important is that those variables cannot have exponents. So just to write down a few examples of linear relation equations, is the first one we can talk about is when it has one variable. So some common ones that you might see, say is if we have x is equal to positive 4, here we have a variable that does not contain an exponent. We could also have y is equal to negative 1. Here we have one variable with no exponent. Let me also show another example where we have two variables. So say we have y is equal to 4x. Here we have two variables, none of which have an exponent. And then one last example is maybe we have y is equal to negative 2x plus 3. So here we've added on an extra number, but we still only have two variables and neither of them have exponents. So these here are all examples of linear relations. And if you were to graph them, they all make a straight line, whether or not they're straight up and down, so a vertical line, horizontal, so going left and right, or having a diagonal line, which could be going up or down going from left to right. So we're going to look at example number 2a and b from your notes. And here we're just going to be looking at graphing these equations. So this is a bit of a review from grade 9. So in this first equation here, we have x is equal to negative 2. So this one here is kind of special because there's not a whole lot of work that we can do for this type of graph. If it makes your brain happier, if it makes you feel a little bit better, you are more than welcome to do a table of values. But with this one here, your x value is always going to be equal to negative 2, so it doesn't matter what your y values are. So here I'm just going to make my table values just to show what might happen. So no matter what y is, maybe y could be negative 2, it could be 0, it could be positive 2. It doesn't matter what these values are. Your x value is always equal to negative 2. So you'll write down negative 2 for your x values. So no matter what happens, no matter which y values you choose, this first set, these x values should always be negative 2. So then when we are trying to graph, our first step here that we must do is we must label our x-axis and we must label our y-axis. So that'll be very important because I need to know how you guys are labeling your spacing, and when you guys are labeling your spacing, you guys don't have to label every single line, but it would be very much appreciated if you could label every second one, maybe every fourth line, just so I know what the pattern is. So when we're talking about our spacing, I'm first going to talk about our x-axis here. So here we need to make sure we fit all of our x values here, and here I guess the only one that we have is negative 2. So for the most part, I always like to see a good chunk of the graph on your Cartesian plane here. And for this one here, it's kind of hard to do that. So what I'm just going to do is I'm going to see, well, how can I fit negative 2 on there? And there's, I believe, 10 lines on here. So I could even choose maybe every 4 lines as 1. 1, 2, 3, 4. So I'm going to the left, so I'm going to be using my negatives first. 1, 2, 3, 4. My next one here will be negative 2. I do want to label a few on the right-hand side as well, just to make sure that my labeling is proper. And then I also need to do the y-axis. So one thing that's important about the y-axis is it doesn't have to go up by the same values that you did for your x values, as long as they just go up by the same number in terms of your y values. So here we want to fit positive 2 and negative 2 on our graph. So if we're looking at our x-axis spacing, this one here actually fits the 2 and negative 2, so we can go ahead and use that exact same spacing, where every 4 lines is equal to 1 value. as I said, just do a couple labels on the positive y-axis. You can do a couple on the negative as well, just to make sure that your labeling is very clear. And then when you have labeled your x and y axis, you're good to go to start graphing. So here we have our first coordinate is x is equal to -2, y is equal to -2. So I'm going to go over to x is equal to -2, up to +2, or sorry, down to -2. I'm jumping the gun here. I'm going to put a value there. Then I have -2 and 0. So that's at x is equal to -2, y is equal to 0. And then my other value is -2 and +2. When I have my 3 points, I can go ahead and use my ruler since we're working with a straight line, and I'm going to connect my dots. And I apologize, I do not have a ruler, obviously, for my computer. So yours should hopefully look a little bit straighter than mine, although I'd like to say that mine actually wasn't all that bad for having pretty shaky hands. So here what you notice is that when we have an equation where we have x is equal to some sort of number, we have a vertical line. So something happens very similar if we have a y is equal to some sort of number. Just instead of it going straight up and down, an equation with y is equal to, with only a number, will be a horizontal line. So it would be going straight left to right. So it'd be lying down. So now we can move on to example B. So here we have the equation y is equal to x plus 25. So this one here has two variables. So this one here will have a little bit of a different graph. So when we have two variables, this means that we're going to have a graph that is diagonal or it's on a slant. So if we have one variable, it'll either be going straight up and down, so going vertical, or it could be going straight left and right, which would be a horizontal graph. And with any kind of linear equation, I always recommend to choose at least a minimum of 3 points for your table of values, because if you made a mistake with one of your values, then when you graph it, you would see that it would not create a straight line, and that would tell you that you made an error. So I always recommend to use at least 3 points, and that way you can double check to make sure you didn't have any calculator errors. So our first step here is to create our table of values. And for this type of equation here, we're going to choose our x values, and then we calculate the y values. And just by looking at my equation, I have y is equal to x plus 25. So when I have this plus 25, this tells me I might have some pretty big values. So if I choose some pretty big x values, I might be able to space out my graph a little bit nicely, so that way my y values aren't insanely huge. So maybe what I could try doing is I would go -10. You could maybe even do -5, but I might just try jump into 0, and then I might do +10 as well. So this is that way I can evenly space everything out, and that way I don't just see a small little portion of my graph. But honestly, if you guys went with some different values, that's okay. As long as you guys did your did the calculations right and graphed it properly, that's fine. But also kind of show you a little bit why, or a little bit more of a reason why I went with the values that I did. But this really only takes practice, and able to so that way you're able to kind of see where that graph is going. But anyway, so back to our table values. So what I do with each of these values is that I'm going to plug in this -10 in for x into my equation, and then I solve for y. So here I have -10 in for x. So I have -10 plus 25. -10 plus 25 is +15. Then I have x is equal to 0. So I'm going to plug that in for x. So here I have 0 plus 25. That's equal to 25. Then I have x is equal to 10. So I'm going to go 10 plus 25. And that one there is equal to 35. So here I've got a pretty nice range for my x and y values, which is really nice. And so now I can go ahead and start to graph, or I need to first label my X and Y axis. So with my X values, I need to make sure I can fit up to -10 and +10. So with this one here, you have 10 lines going straight across on the right side and your left side. I might recommend to go, you might want to go every one line is one, but I might do every 2 lines, just that way I can see a nice good spread of my values, so I can see the relationship and see clearly that it is a straight line. So I might go every line is 2 then. So I'm just going to label every second one, just because it'll get a little bit crowded if I try and graph it otherwise. So here we have 4, 8, 12, 16, and 20. So every line represents 2. I also need to go in the negative direction as well. You guys can see that even this here is a little bit squishy, which is a really good reason why we don't want to label every single line, because then it's really hard to start to read, or when we're trying to read your graph. Okay, so now we need to worry about our Y values. So for here, our highest value here is 35, so we need to make sure we can fit up to 35 on there. So this one here kind of shows that we don't have to have our same spacing for our X values as we do our Y values. Because if we went with our previous one, we'd only get up to 20 and -20, and that wouldn't be enough. So what we could go up by is, we can go up by 10. Or every line is 5, which every second line is 10. So here, if you can see, we get to 35, which is using, that's using a really good chunk of our graph. I usually say you should use at least half to 2/3, so that way you can really see the idea and the relationship that's going on with that graph. And once you've labeled that, you guys are good to go to start graphing your values. So here our first coordinate is X is equal to -10, Y is equal to +15. So I'm going to go over to X is equal to -10, which is right in between -8 and -12, and go up to 15, which is right in between 10 and 20. So there's our first point. Then our next one here is 0 and 25. So X equal to 0 is right at the origin. Go up to +25. And there's our value there. Then we had 10 and 35. Let's go to X equal to +10 up to +35. So then once when you've graphed each of those coordinates, then you guys can go ahead and grab your ruler and connect those lines. So for me here, I don't have a ruler. So please excuse my non-straight line. Okay. So here, if I were to use a ruler, which hopefully you guys did, you guys would see this creates a perfectly straight line, which is really great. And so just to recap is that if your points did not go onto a straight line, it means that you made an error somewhere. So that's why I always recommend to do at least 3 points when you guys are doing your table values. That way you can clearly see if you've made an error. And that's also assuming that you didn't make the exact same error in every single coordinate on that table values. And one thing just to say is that with each of my graphs as well, make sure you guys put on arrows at the ends, just because that indicates that you can extend your graph and it goes on. Just because you chose just because you chose these coordinates doesn't mean it stops. So you must put arrows on the ends of them to show that they can keep on going. So that is everything for this video. So if you guys have any questions, make sure to come see me in class, or you can text me on Remind 101. And thank you guys so much for watching.